A warm welcome to all viewers. In this session, we will going to learn about corrections to basic runway length. I am Ashok Kumar, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Learning outcome of the today's session. At the end of the session, students will be able to calculate the runway length with applying the various corrections to the runway length. In the previous session, we are already learnt about how to calculate this basic runway length by applying three methods: by normal landing case, takeoff case, and engine failure case. So after arriving the basic runway length, we need to increase the runway length by applying certain corrections. So these are the basic runway length as per the International Civil Aviation Organization for the different types of the airport from A to E. So these are the basic runway length and the respective width of the runway as well as longitudinal gradient of the runway. Now why we are going to apply the corrections to the basic runway length here? When these are the standard conditions at the mean sea level is taken, if the values deviating from these standard conditions, it may be pressure or it may be temperature or air density, we need to increase. What are the standard conditions we are going to take? Temperature at mean sea level is taken as 15 degrees centigrade, and pressure at MSL it is 760 mm of mercury, and air density 1.225 kg per cubic meter. If there is any variations from this standard condition at the sea level, we need to apply the corrections. What are the corrections we are going to apply? Correction for the elevation and temperature and gradient. Let us learn all these three correction and how to increase the length of the runway by all these three methods. The first correction is elevation correction. As you see that higher the elevation of a place, the density will be going to be lesser. As you go higher altitude from the mean sea level, the density will decreases. So due to that, it requires the engine to put a more force, or it requires a longer runway to accelerate the speed and go into the air. So due to the decreasing of density, this is due to the thin air which is not giving much push. It may be on the wings of the aircraft. We need a lift off. So due to that lower density, this lift off will be lesser. So to compensate that the lower density, either we are going to provide a longer runway or by taking a less payload. But payload will be always be higher. We need to increase the runway length. So from this diagram also you can understand, from the nearby the earth, we will be having high pressure and high density because all the air molecules are condensed each other, they are in together, and due to that the pressure will be very high. And as you go in altitude, you can see the density is also decreasing and air pressure is also decreasing. So both temperature and your density will decreases. So here the air molecules are dispersed in the atmosphere. They are like expanded in the atmosphere. So due to that, the pressure will be lesser, and due to the pressure, the liftoff will not be easy for the aircraft. So it needs to be traveled for longer distance to get that the power to go into the air. Now you pause over here and think for a moment, why temperature and air density decreases with altitude? I hope you are able to get the answer for this. So we have a troposphere, stratosphere, mesosphere, and thermosphere. So we are in this troposphere. So our flight runs from at about 10 to 11 kilometer over here, and this is our mountains, Mount Everest. So in this case, so here, as you increase the elevation, there is a less air above you, and thus the pressure also decreases. As you told in the previous slide, as you go in higher altitude, the pressure will be very lesser. As the pressure decreases, air molecules spread out further. So air molecules are spread in the atmosphere. They are not condensed each other. They are not in a large mass. So they are expanded, they are into the air, and due to that the temperature decreases. So once the temperature decreases, your pressure also decreases. So once the pressure decreases, your density also decreases, and that will leave the lesser lift off on the aircraft. That is the reason we need to be increase the length of the runway to take the correction of elevation as well as the temperature. And due to the density, what is the reason for the lesser density? You can get an idea. There is a less air pushing down from above, and gravity is weaker. So if you are coming closer to the earth, the gravity is there, and the earth is very warmer, it can absorb the heat. And over here, as you go away from the earth, the gravity will be lesser in that case. So from there, so at higher altitude, air molecules and can spread out more, and air density decreases because they are not into the if you take a mass of those the molecules, it will be very lesser because they are not together. They are spreaded or expanded in the atmosphere. That is the reason the density and the pressure will be very lesser. So once that the pressure and density is lesser, you know that this liftoff is very important for the aircraft to go into the air as early as possible, because the runway length is restricted up to 2.4 or 2.5 kilometer. But if you the density and pressure is lesser, this liftoff will be very lesser on the wings of this aircraft, and due to that the pilot requires some more distance to get that the liftoff and go into the air. Now correction for elevation, as I told you, air density reduces as the elevation increases, and this results in the lesser lift on the wings of the aircraft. So this reduces the lift. So due to that, aircraft will require more ground speed to rise the air or achieving a more speed. So to get the accelerate or to go into the air, the pilot requires a more distance. That is the reason we are going to apply this correction. Hence, the longer length of runway will be required. So as per the ICAO recommendation, International Civil Aviation Organization, so what is the basic runway they are going to apply the correction? So already you know the basic runway length is given to you. For that, you are going to increase that basic runway length at a rate of 7% for a 300 meter rise in the elevation. So every 300 meter rise in elevation, you are going to increase the 7% above the mean sea level. Suppose example is given over here. So you have a airport elevation of 100 meter, and basic runway length is given to you 600 meter. Calculate the actual runway length over here. So here you can see that for 7% for every 300 meter rise, for 100 meter elevation, given elevation, what is the rise you are going to get? So you just cross multiply that, and for a given basic runway length, we need to multiply it. So this is 14 meter is what the additional length is required. This is the airport elevation is above the MSL of 100 meter. For this 100 meter rise in elevation, we are going to add 14 meter extra additional length to this basic runway length. So now the runway length is 600 meter plus 14 meter. So 614 meter is the runway length after correction of the elevation. Now coming to the temperature correction. So as I told you, even rise in airport, here we are going to talk about not the normal temperature. So here we are going to introduce the word airport reference temperature. So we are going to calculate this airport reference temperature, and we increase the length of the basic runway length by considering the airport reference temperature. I will tell you how to calculate this airport reference temperature, and same effect as the density is increasing, or the effect of the elevation is having the same effect on the wings of the aircraft. That is also the reduction in the temperature. The reduction will be approximately minus 6.5 degree for every 1000 meter rise in elevation. The temperature drops down as you go higher and higher. The temperature will be minus 6.5 degree per centigrade per every 1000 meter elevation. So that also reduces the air density, and that will have an effect on the lift off of aircraft of the wings. So that is the reason we are going to increase the length after the elevation correction. Again, what is the correction we are going to apply? So whatever the length it is considered for the elevation correction, so in the previous case 614 meter is that. So taking the 614 meter, we are going to further increase the 614 meter at a rate of 1% for every 1 degree rise in the airport reference temperature. So for every 1%, we are going to increase the length of the basic runway length at every 1 degree centigrade in the increase in the airport reference temperature. So how to calculate the temperature correction? So first of all, you need to calculate the ERT, that is airport reference temperature you need to calculate. After calculating the ERT, you are going to compute the standard temperature at the given elevation. So that is ST we are going to calculate. So after calculating the ST, you are going to calculate what is the increase in the ERT, airport reference temperature. So ERT minus ST will give the ERT value, airport reference temperature. And then for this, the increment, we are going to apply the correction, that is whatever the 1% for 1 degree rise in the airport reference temperature, we are applying the correction. So after third step, we are going to apply the correction. So how to calculate the ERT? Here it is given. It is the defined as the monthly mean of average daily temperature for the hottest month of the year. So we are going to take the hottest month of the year, and in that the mean of the average daily temperature is indicated by TA, and plus the 1/3 the difference of the temperature and the monthly mean of the maximum daily temperature for the same month of the year. So basically we need two details over here, one TA and TM. One TA indicates the monthly mean average daily temperature for the hottest month of the year, and monthly mean of the maximum daily temperature for the same month we are going to take. So having TA and TM, you can able to calculate the what is ART. These are the references I have used for preparing this presentation. Thank you.